Good afternoon. I want to welcome everybody. My name is Steve Cohen. I'm Executive Director of the Earth Institute, and I'm happy to introduce this session today on open data and the future of funded research. As you know, the panelists here are going to discuss the advantages of sharing data openly, as well as the practical implications for researchers, particularly those who work with confidential information or who plan to mine a data set for years to come. This is the third of six events for this academic year in the Research Without Borders series on issues in scholarly communication, sponsored by the Center for Digital Research and Scholarship's Scholarly Communications Program. So let me introduce the three speakers to you. Beginning immediately on my right is Dr. Robert Chen, who's the director of CIESIN, the Center for International Earth Science Information Network, a research unit of the Earth Institute at Columbia. Bob is currently the Secretary General of the Committee on Data for Science and Technology of the International Council for Science and a member of the ICSU Ad Hoc Strategic Coordinating Committee on Information and Data. Bob is also the person in the Earth Institute that we count on to promote issues of cyber infrastructure and data sharing throughout the world. Seated next to him is John Wilbanks, who is the Vice President for Science at Creative Commons, where he runs the Science Commons Project. His background includes stints at the World Wide Web Consortium, the Harvard Law School, and the U.S. House of Representatives, as well as having been a software entrepreneur. At least you haven't been a hedge fund trader, so that's good. He has a degree in philosophy from Tulane University and studied modern letters at the Sorbonne in Paris. But I understand he'll be speaking to us in English today, so that's a good thing. And next to him is Dr. Andrew Rundle, who is an Associate Professor of Epidemiology at the Mailman School of Public Health. And he runs several research projects studying how built and social environments of the neighborhoods in New York City influence health. He uses GIS tools to study very large human health data sets linked to geospatial and administrative databases describing the characteristics of New York City. And to a large degree, his research depends on access to data generated by New York City government agencies. And so he has an interest in making sure that that data is useful and open. So with that, let me ask the panelists to begin and provide you with what I'm sure will be some spectacular presentations today. Gentlemen.
Thank you for the introduction, and thanks to Bob and Catherine and the libraries for the invitation to speak today. So since I'm going first, I'm going to try to set a little bit of context for the more detailed stuff that Bob and Andrew are going to say. And the rationale for data sharing that we work with at Science Commons is that data gets more powerful if it gets linked up, if it gets connected. And this is sort of a fundamental principle of networks, which is that when you connect things, they tend to get more valuable if they're at least digital assets. But to do for data what we've done for the web and what we've done for computers with Ethernet and TCP/IP and HTML takes more infrastructure than we currently have, and it takes a fair amount of innovation. And this is a great quote about innovation, which I picked up from one of Larry Lessig's books. And it's a quote that sort of seems very modern when you read it, and it's about the fact that people who prosper under an old regime are typically the people who don't like innovation to happen. And this is actually a very old quote, and it's from The Prince by Machiavelli. And so changing the way that established power structures do things has always been fairly difficult. And there's not much more in terms of an established power structure than the scientific funding infrastructure. Remember, the name of this isn't just open data, it's open data and the future of funded research. And funded research means that for the most part, unlike web pages and internet servers, science and knowledge and data get created in institutions that get funded by funding organizations. And so there are different opportunities for control at each layer of the stack that don't really operate on the web and on the network. They don't operate on eBay, but they operate on data and the transformation of data into knowledge. There's actually, you've got a great bag that says without knowledge, it's just data. But that transformation tends to happen in these institutions. So how do you get after changing institutions? And one of the only models we have is interoperability. So technical interoperability, the way that networks work, is a very good inspiration for what we want to do with data. But in the beginning, technical interoperability is simply a stack of different technologies that separate concerns. This is what's called the semantic web layer cake. It's an example of the simplest way, supposedly, that you could connect data technically. And so it has things like the markup language that you would use, whether it's XML or RDF. It would have schemas and query languages. And then you've got sort of this tiny little bit up at the top, which is trust, which sort of cracks me up, that trust is such a small piece of the cake. But this is sort of the minimum amount of things you would need to do from a technical perspective to achieve interoperability in data. And if you are successful there, then you wind up with the semantic problem, which is that computers don't really understand what anything is unless we tell them. And so I'm making what I hope is a fair use of a Far Side cartoon. And so when, what we say to dogs and what they hear, this is sort of like what computers hear when you tell them about a data set. They sort of see blah, 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 URL, blah, 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 blink tag. They don't know the meaning of the content in the data set unless we make it clear. And so even if we somehow magically agreed on the technical stack, we'd have to at some point come to consensus on what things mean for computers to begin to hook them together in the same way that computers hook together web pages and servers. And one of the biggest barriers to all of this is the law, which is that the law was designed for copyrighted works of knowledge, for patented works of knowledge, for trademarks that represented brands, for trade secrets. It wasn't designed for this really weird world in which there were gigabytes and exabytes of data linked up by computer networks. That wasn't in the Sonny Bono Copyright Term Extension Act in 1995. And the name alone should give you a context of who was driving this. It wasn't scholars, it was content companies. And so Creative Commons, which is the org I work for, has been trying to bring legal interoperability to the cultural copyright space. And we've had some good fortune there. And the idea was that the law should have an interface in the same way that computer networks have an interface. So if you want a copyright license, you answer 2 questions. Would you like to allow commercial uses? Would you like to allow derivative works? And if you choose to allow derivative works, you can impose a requirement that any new derivative works be shared the same way. And it creates this set of what we call human-readable licenses. So as a creator, you understand what the rights are that you're giving to your users, or as a user, what the rights are that you have. And from a legal experiment, this thing exploded. It grew like the network grew. And so this is data as of 2008. It's doubled again in 2009, mainly because of the addition of Wikipedia this year to our licenses. But what this sort of shows you more than anything, and we're a nonprofit, everything we do is free, all these legal tools are free. But what it shows you is that there's sort of a hunger for interoperability at the legal level, because you sort of want to make the law go away if what you're doing is remixing and reusing cultural works. And so we've been looking in the science part that I work on what do these core aspects mean in the context of data and data interoperability. Because these 4 toggles here have almost become code for sharing in the cultural space. Well, we all want attribution. We want credit where credit is due. Well, non-commercial, we all intuitively know what that is, but it's actually fairly hard to define legally. Is it a commercial work if it's a Columbia University undergraduate student who's using Google AdWords to pay for her hosting costs on her blog and she blogs about science? Right? It's kind of hard to standardize that in a scalable way. This is hard enough in the cultural space. It gets even harder in the data space. And then things like no derivative works. This might be really interesting if you're a photographer and you want to make sure no one takes your photographs out of context. Or if you're a musician and you want to make sure that the work is preserved in whole, but you do want to let people make and distribute copies. And then if you want to impose some sort of share-like constraint, if you say, I'm willing to let Bob make remixes of my techno music that I make on GarageBand in the plane, but he's got to put them back online under the same licenses. Now again, when you're dealing with atomic cultural objects like songs and photographs, it's fairly clean to know whether or not that right has been maintained. But the law on which this rests doesn't really work the same way in the data context. And from an interoperability perspective, choice is actually at odds with interoperability. So this is a chart of our licenses, right, against each other, licenses that can be used for derivative work or adaptation. And the green blocks represent interoperability from a legal perspective. So the public domain is interoperable with everything. You can add public domain stuff to anything without constraint. Attribution is the only thing that it can't be combined with is essentially the public domain. You have to basically, anything that goes from public domain and gets mixed with attribution becomes an attribution product. But when you get down to attribution, non-commercial, no derivatives, you can't do anything. It's only interoperable with itself, and it grants no real rights to the user other than the right to just copy things. And it might be useful to copy a song because I can listen to it, but there's not much use in copying data if you can't do something with it. Right? Data is the foundation, not the end. And this tension, right, really is between choice and interoperability. And one of the sort of great things about the internet is that there is no choice if you want to be on the internet other than to use TCP or to use IP. Right? These are the core foundational protocols of the network stack. If you want to be on the web, you use HTML. These are open, voluntary monopolies that were achieved without traditional intellectual property. They achieved because they worked. They created the connectivity. And this is the classic math behind it. It's called Metcalfe's law. And the idea is that the value, right, the economic value of compatibly communicating devices grows at the square of their number. And there's debate over whether it's actually the square or if it's a different coefficient. But there's not a lot of debate over the fact that connecting devices into a compatibly communicating system increases their value. And so the real question of this panel to me is, how do we achieve this for data? How do we make data compatibly communicate so that we can begin to get some of these values for it? And what I think, I saw a little bit of Andrew's slides, you're going to see in his slides, especially the value of taking data that wasn't generated for interoperability with another data set and munging them together, because it lets you ask questions you couldn't have asked without those two different data sets. And the designers of each of those data sets might not have ever intended them to be combined. And so the question is, the way the network lets us do this for devices and for documents, we need for data. And so from a legal perspective, which is what we work with for the most part at Creative Commons, data isn't a creative work in the eyes of the law, at least in the United States. And it's important to realize that free software licenses, free culture licenses work for the most part because of the existence of a relatively harmonious, relatively international law, which is copyright. So if I give Bob a song and he gives it to Andrew, and it was a Britney Spears song, Britney can sue all of us because the copyright goes with the song wherever we go in the world. Now the time and dates and lengths of it might change a little bit, but for the most part, it's relatively harmonized. It's not like that with data. So data in the United States, for the most part, raw facts of nature, are not considered to be subject to copyright. So like the telephone book is the canonical legal case in the United States. Didn't matter how much time and effort you took assembling the telephone book, addresses and phone numbers arranged alphabetically aren't creative. They're data. Now, in the UK and other English law countries, there is a copyright on data. It's sort of a light copyright. And then the European Union in the mid-90s, to protect their data industry, passed a law that actually created a copyright-esque right on data. And it's called a sui generis law because, like the duck-billed platypus, it's right one of a kind. The other laws like this are for ship hulls and for mask works on microprocessors. Oddly enough, the American database industry has exploded since the creation of the EU database directive, and the EU data industry has not, which indicates empirically that the law did not create the protections it was supposed to create. But what we have then is essentially an international system that's completely fractured, which makes it very hard for scalable networks of licenses like the Creative Commons licenses in culture for copyright or free software to work for data. And data is actually a pretty bad fit for copyright. And so I think visually, and this is basically when you try to hammer data into a copyright hole, you mess up both the copyright legal aspect of it and you mess up your data. Because creative works, which are what copyrights govern, come from this sort of magic right of the author, where you lift your hand from the paper and the copyright attaches to the paper. So this presentation, I don't have to register a copyright for it. And the copyright was going to last 70 years after I die. That's how far into the future copyrights go in order to protect creative works like Mickey Mouse and other systems. Remember, Sonny Bono, Copyright Term Extension Act, not Albert Einstein, Copyright Term Extension Act. And so think about the aspect of having 70 years of prevention of copying of data after the death of the scientist who created it. Now, the other weird thing about this international regime is that you might create it someplace where there's a copyright, but if I get a copy of it and republish it in a place like the United States where there isn't one, unlike the Britney Spears case, you can't come after the person who downloads it from the United States. Right? If I can prove I got it from a US server, then the odds are pretty good that I'm in the clear. And so that makes licensing things hard. And so let's go through the Creative Commons terms. Since these are shorthand for sharing, let's look at them one by one. So non-commercial. Again, this makes a lot of sense if you're a musician, you want to post a song, you don't want Ford to put it into a car commercial, you put it online under a non-commercial license. But what's a commercial use of linked data? This would be sort of saying, well, if someone at Pfizer runs a Google query, is that a commercial use of the web? And if we're going to have a linked data web, if we're going to have Andrew's epidemiological data coming online, if we're going to have Bob's climate change data coming online, is it a commercial use if someone who gets paid to look at data runs a query against it? Is it a commercial use if they make a copy for research use locally at their company? Is it a commercial use if a startup uses it in order to make a decision about whether or not to go forward with a project? This sort of constraint on data in the early stages actually is pretty toxic to data interoperability. And if you think back to the web's early days and the internet's early days, there were no such constraints. So when the web was released, Tim Berners-Lee made the code public domain, didn't patent the process that he went through, and then he basically enabled widespread copying through view and edit source. And in the early days of the internet, again, widespread copying was how the internet began. And constraints on who's allowed to do that actually would have been pretty toxic. So non-commercials, we looked at that, we said we can't use those terms. Share alike. So this is typically called copyleft, and it's the idea of imposing the idea that if you're going to share, the next person needs to share as well. And this is the key idea behind free software licensing. And this is the icon. And if you think about, there's a lot of different things that are not really consonant with something like share alike. And so privacy is completely incompatible with share alike. Changing data formats, linked data, scientific norms, national laws. So whatever you do, no matter how much you try to sort of mash licensing terms like copyleft with data, you can make an emulsion out of oil and water, but they don't ever truly mix. And that's what you find when you deal with share alike in data as well. And once we had a group that gave us this as an example. This is John Snow's cholera map from London in the 1800s, and this was one of the earliest examples of epidemiology, so I've got it up in honor of Andrew. And the modern version of this, so these are this is a street map, and then the dots are deaths, and the X's are wellheads. And it was sort of the core of convincing them that cholera was actually water transmitted. The modern version of this would take a street map database as opposed to an actual picture of streets, and it would take clinical study data about disease incidences in a neighborhood. And that disease data carries what's called HIPAA, or privacy constraints. And if the street map data carries a copyleft constraint, then you can't put the two together, because copyleft systems typically say you cannot combine data with this data that can't also be released under copyleft. That's how most of those terms work. And the existing data licenses that attempt to impose copyleft-style systems have had to deal with this through some systems where you have a choice. Either the copyleft works and it's viral and it forces people to be open, or it actually doesn't get reached through an enforce and it allows interoperability. You don't really have the ability to sort of force people to be open in data because you don't have that big, powerful right. And even attribution gets complicated. So this is something that intuitively we think citation and credit where it's due. This ought to be scalable. But in the web world, so this is one page of attribution for Wikipedia. And so each of these is a name, and they're an incredibly tiny font. And the most current printout required 27 pages of attribution like this. So again, project this out 10, 20, 30, 40, 50 years. Because it's built on copyright, any one person can bring it down with an injunction if they feel that they're not being attributed properly. And that's not a very stable infrastructure for a long-term web. And again, in a large cultural work like Wikipedia, where we have a copyright system which is relatively harmonious and international, we can mitigate some of these things. But in data, we don't really know what it looks like because copyright and data are such a bad fit. And even worse is, what if you simply use something by linking to it? You haven't copied it, so you haven't triggered any copyright licenses. And what you find is that over and over again when you deal with this, that you can't meet the expectations for data that have been generated for software and for culture, which is the expectation that you can force people to behave nicely through the law. And it's going to be relatively cheap for you to do that. And that's a power that comes from copyright that we just don't really have in data. So what we've been doing is working on the public domain as the substrate for data. We have this thing that we came with a very sexy title for, which is the Protocol for Implementing Open Access to Data. And the whole idea behind this is interoperability of scientific data. And the idea is no law rather than free law. The idea is that you want first to waive all of the rights that are necessary for extraction and reuse. So there are copyright things that attach to pieces of databases, like the way they look and the way that you load data in. So you need to waive those so that your user doesn't have to figure out where the copyright stops and starts. You don't impose obligations, even ones that would in theory make it more free, to limit downstream use. Because in the beginning of a web, any friction is too much friction. And the way to deal with this is to request behavior through norms. So the human genome is our example here. The human genome is in the public domain. And the scientists who participate in the projects related to the Human Genome Project use norms to guarantee compliance and behavior as opposed to the law. And this is something that's not particularly controversial in the big sciences, at least yet. So this is an article, an opinion piece from Nature in September that came out and endorsed the public domain approach. And we're seeing it adopted by more and more open science approaches. So this is the Tropical Disease Initiative. It's a kernel of drugs that bind to disease targets for rare and neglected tropical diseases. This data is in the public domain. The Personal Genome Project, which is going to take 100,000 genomes, health interviews, and sets of stem cells and make them available with the minimal sets of constraints in the public domain. Being picked up relatively quickly, we now see a BitTorrent network for massive genome files being transmitted around under the licenses. They were wary of using the data previously because they didn't know where the rights stopped and started. And even in Europe, where the database directive is very popular from a freedom quote-unquote perspective, there's a beginning of waiving those rights in order to preserve interoperability. This is from the European Molecular Biology Lab. And sort of most surprisingly is that companies in the United States like Merck have begun to adopt this approach. So Merck looks at this and says, well, we put terabytes of gene data into the public domain in the 90s, and it actually had two beneficial effects. One is it created a standard around the way the gene data was organized, and that helped us from a technical perspective. But it also kept bad patents from being issued by creating a lot of prior art. So Merck is taking the entire disease biology platform they spent a decade building, moving it into a nonprofit organization, which is putting globally coherent data, including intermediate traits, variation, clinical traits, and basically putting it all into the public domain as well as the software needed to make that data into disease models. And so SAGE is the nonprofit that's doing this, and the whole idea is that no matter what deals the organization does to stay funded, everything they do moves from left to right. So the data moves into a public domain, the code moves into a free software repository, and all the documentation required moves under a CC license. So the companies are sort of figuring this out in many ways faster than the scientists are. They don't have the same barriers to change and funding in many ways. And then sort of most relevant to Bob here is that he's been part of pulling us into this thing called the Polar Information Commons, which is a global repository of information about the poles from a climate perspective. And this is a big international effort. You see all the acronyms down here at the bottom and all the logos. And when you want to actually integrate that information, it's much easier to say that we're going to use ethics and norms to do that instead of the law. Because otherwise, bringing together the laws of all of the various countries and the lawyers from all the various institutions is almost NP hard. Right? Getting lawyers to agree on single basic standard contracts for things, even to give them away, is really, really complicated. So we've been very proud that the Polar community has done this as well. So with that, I'm about done, and I just wanted to sort of take this back from Merton, who's a famous sociologist of science. And I think it's an important principle that we go back to because, again, it's very easy to fall into the trap of having our thinking guided by free software and free culture, which starts with private property, creating property through its licensing. And in science, it's a little different. And it's always been the case that you create property in science by giving property away. That's how you, by sort of enlightening other people, by publishing your knowledge, that's how you get credit for it. And so we have to think about that as the first principle as we move into open data systems, and simply get the law out of the way using the public domain. Because the models that we have for culture and software, if we port them in, they might have unintended consequences that don't give us the sort of freedom and openness that we want. Thank you.
So I've followed, or I've seen John talk, and I know it's hard to follow his kind of presentation. It's very polished and crisp. So we'll see, and it's nice that he gave me several segues that I'll get to. I kind of changed my title around because when I was thinking about it, it's really about together open data and research as a package. And I'm going to step back a little bit also and not just come from where John's coming from, but go back to a little bit of this ethics and norms issues, which has come up in a few contexts. One is something called the World Summit on the Information Society, and a few other activities I'll mention. So one of the foundations, I guess, of thinking about this is the Universal Declaration of Human Rights, in which, buried in Article 27 is this idea that science, the products of science should be shared by all. It is property, but the benefit is giving it away and having it benefit everyone. And that's been taken up by this international body called the International Council for Science, which is a international organization with members of all the academies of sciences of countries. And they have a statute which talks about the equitable access to data, information, and research materials. And this is something that our U.S. Academy has bought into as representing the scientific community here. And the idea of, it was based partly in the Cold War and other areas when scientists weren't allowed to communicate, but the scientific community insisted on free exchange and interaction. But it carries over, I think, into the modern age now, talking about digital divides between North and South and so forth. For the developed countries who are members of the Organization for Economic Cooperation and Development, it's actually a very interesting document that came out 2 years ago called the Principles and Guidelines for Access to Research Data from Public Funding. And this was an effort really to establish a norm that if you're getting taxpayer money as a researcher, you really have an obligation to make your data and results available openly. And the first principle is this openness, which is not necessarily free access, but open access to scientific results. And it actually goes on and says, you can't just hide, it can be open but hidden somewhere. It should be easy to get to on the internet and so forth. All these documents are online. I have a copy of the OECD principles here. Actually, John just showed one of the papers from this issue of Nature and their particular editorial, which really is part of a slow process of recognition of the need to open up access to data. This was an editorial that the president of CODATA and I published a few years back in conjunction with the World Summit. But, trying, again, not legislating, not legal, but trying to set the expectation in science to open up access, to worry about the digital divide and data and technology transfer and so forth. So that's sort of the basis of coming at it from science. The next thing I thought is important to say is why is it important? And I think it was mentioned, this is co-sponsored with the Earth Institute, this symposium, so I'm going to talk about it from the Earth Institute perspective. It kind of goes without saying that climate change is a pressing issue, and this is data from our, which was partly developed by the Goddard Institute for Space Studies just down the block, looking at how, in fact, climate change is already happening. We don't have to predict it. It's actually been observed to occur and have substantial impacts already. If you look at the polar data, It's just amazing how much has been happening. The lowest sea ice extent occurred 2 years ago in 2007, and there's 2009 is not quite as bad, but it's still low. This is something you can monitor on the National Snow and Ice Data Center website. And if you look at places like Greenland, they also has had much wider melting than in the past over the last couple of decades. I could go on forever, but you know, it's happening in the Antarctic, it's happening in mountain glaciers around the world. Clear signals in the cryosphere. And the study that I alluded to looks at data from the cryosphere, from the ecological systems, from terrestrial and marine areas showing, you know, evidence of climate change already happening, and of course leading to the idea that it's going to continue happening. And of course, there are lots of other reasons why we need to share data. Hazards are still pretty deadly, emerging infectious diseases, all sorts of problems for which sharing of data is really vital. So one thing that's happening is lots of people are investing a lot in collecting more data. So hundreds of satellites in planning. NASA has a whole new set of missions planned for the next decade or two. Lots of data being collected, but in the traditional mode, all very stovepiped. So, you know, a country or a company or whatever collects the data to sell or to make available to their own researchers, not necessarily share. And so there is an international initiative called the Group on Earth Observations, which is trying to develop a unified global system, something they call GEOS, still under development, not really there yet. But it's an effort to get these stovepipes to interoperate. Of course, the initial focus has always been on the technical interoperability, all different formats, ways of collecting data, continuity issues, different types of data that are difficult to integrate, both remote sensing, satellite, and GIS, and surface observations, and so forth, all trying to be put into one system. So there's a big technical problem. But of course, in reality, one of the sleeper problems is the one that John's talked about. How do you actually get these data to work together from a legal and institutional viewpoint? Because again, not all countries are like the US that just says, all the data we collect is in the public domain. In fact, not only are there countries like the Commonwealth ones that have copyright, but there are a lot of public-private hybrids where just the tiniest bit of private money put into what is 90% taxpayer suddenly makes it basically the province of private property. And you know, that's a really unfortunate situation. Actually, the university does that too. You see that here at Columbia and elsewhere, where just, you know, it's federally funded, but we put in 5% from a private source, so therefore we control it and we don't have to open it up. So that's, you know, on the basis of it, not very fair, let alone ethical, I don't think. So within GEO, there's a set of data sharing principles that were established up front, and they're kind of good. They call for full and open exchange of data, but the fine print does say, you know, recognizing relevant international instruments and national policies and legislation. So it's always a fine print of legal documents that kill you, right? So one of the efforts that I've been involved in is to develop implementation guidelines for these general principles. And you know, one of the points was really, sure, there are reasonable and necessary exceptions, protecting indigenous peoples, protecting endangered species, confidentiality, and so forth. But you want the exceptions to be exceptions, not huge things that, you know, everybody uses to get around what is ostensibly open. So we've been involved. There was a paper that was just my first paper ever with 3 other lawyers that came out in the Journal of Space Law and Data Science Journal about 2 months ago. And that's the basis for a set of proposed guidelines that are actually now in the purview of the International Data Sharing Task Force, which is meeting next week and along with the plenary. So I mentioned a lot of polar data because we're also involved with, as John mentioned, the polar community. Some of you may have heard of something called the International Polar Year, which, for example, Robin Bell here at the Earth Institute helped get off the ground. The actual field measurement phase ended in 2008, or actually earlier this year. But they're actually in the process of still working with all the data. And the big issue, in some sense, is what's happening to the data. And so, they had agreed on a policy to make data shared among all the different science groups, both social and natural scientists. But, making that practical and figuring out what happens after this intensive research period is still up in the air. So, in that sense, this is where the Polar Information Commons Initiative comes from. Just stepping back, if you look at the Antarctic Treaty, which is actually in its 50th anniversary is coming up, and that established a legal, physical, real commons for the continent. And as part of that treaty, there were articles that referred to, first of all, free scientific investigation, open scientific investigation in the Arctic with a compulsion agreed to by all the signatory nations, about 48 or something of them, that they would share the results of their research coming from this stuff. The research about the physical commons would be shared openly. So there's at least the legal basis for thinking about a virtual information commons matching the real commons. Arctic is a little more complicated. There are 8 countries that have territorial claims on the entire Arctic region. There's a debate about things like what happens if there's no Arctic ice cap anymore. There's a group that I've been dealing with that, there was a paper, I forget if it was Nature or Science, in which there was the idea that that the Arctic Ocean should be considered open ocean, and therefore law of the sea and the traditional body of law that applies to the open oceans should apply. But there's actually a big legal debate. But whether or not it's a legal commons, one of the issues is there still a basis for a shared information commons that is focused on the scientific data and knowledge that's necessary? Not only because it's in the mutual interest of the 8 parties, but it's because it's in the mutual interest of everyone in the world, given that the Arctic is important to our climate and other things. So that's one of the bases for this Polar Information Commons Initiative. What we want is to establish or make the claim that these are public goods, the data about the poles are public goods, that they ought to be shared, and that we need both the institutional legal framework as well as the technical framework to enable sharing of data. And that we really need to take the internet model that's developed, John alluded to, of really collective, grassroots ability to put effort and time and resources in to creating this without putting a lot of legal and other constraints on it. So we went through a whole process, and we have adopted the Science Commons Protocol. We've been working with John and Caitlin Thaney from Science Commons. We're in the process of developing what we call a badge, a PIC badge, to signify to people digitally that data is part of the Polar Commons. And in the distributed internet, that data can sit anywhere, but as long as it's labeled, it's part of a virtual, collection that people can see as if it were in one place, but it's not really. And a set of community norms. So I think you showed was that from the webpage? Yeah. So there's a draft that's sitting on the webpage, and we've just kind of created and are vetting with some of the coordinating organizations, and then we're trying to vet that with a broader community. And it refers to things like, what do we expect users to do when they use PIC data, and what do we expect contributors to do when they put data in? Reasonable citation. Know if you're using 5,000 data sets in some analysis, we're not expecting you to cite 5,000 individual little bits of data from all those sources, but if you're using it in the way most scientists cite data in a publication, yeah, you should. But you don't have to because it's not a legal requirement. I won't go into too much, but one of the things that I think interesting from the library viewpoint is that we feel that one of the barriers to preservation of polar data is that the archives and the infrastructure that is looking out and saying, well, what's important data? What's useful data? If they actually have to go and secure the data and get the rights of the data from all those individuals, it's a very intensive effort. But if the community has made the data available, whatever form, wherever it is, it actually makes it much easier for archives to go out and mine and look and say, well, you know, if I got that data and integrated it with this larger collection, it would make the original data and the collective resource much more valuable for everybody. So they can just do that because they can find it through the PIC badge, they can know the rights through the CC waiver or a CC BY license, and they can use it and do it without having to do too much consultation. And that's important because, you know, data sources disappear, they change, the authors die, they lose track of things. So having the right up front to use data makes the archiving, the appraisal and selection and hopefully the curation process much more doable from the viewpoint of, you know, the institutions and groups that are interested in polar data stewardship. So, you know, just to kind of sum up, science clearly is important, and sustainable development is very much needs science to help resolve the many challenges out there. Open access has a lot of potential benefits for research and for data. You know, just looking at the need for interdisciplinary work, for making more rapid progress, you know, not having it locked up for 70 years and so forth. It should reduce duplication of efforts. And in fact, that's actually one of the drivers for research funders to actually want to invest in this type of approach, because what they see is a lot of duplication when data is locked up and not shared. And broader community participation. I mean, I think one of the amazing things about looking at the Creative Commons experiences is that people from outside the traditional community come in and contribute and do stuff and put in labor and develop code and so forth. And scientists, there are a lot of examples of participatory science, but this is one where you could imagine even more applications just because people like polar bears or are interested in the topic or whatever. And again, as I mentioned, it's an opportunity to open up the stewardship problem and eliminate at least one of the barriers to the long-term stewardship and preservation issue. So thanks. Appreciate your thinking about this.
Good afternoon, and thank you for coming out, and thank you for inviting me. I'm going to describe the research efforts of my group as a way of illustrating the issues we face with open data. And what you're going to hear is much more chaotic and idiosyncratic and disorganized data issues than anything that my two colleagues have presented, which have been efforts to sort of have organization and principles. And what we're encountering is, in many ways, the opposite of that. And so a lot of what I do is consider how neighborhoods influence the health of their residents and how the characteristics of neighborhoods influence the health. And we're working with this notion of the built environment, which has been defined by NIEHS as all buildings, spaces, and products that are created, modified by people. It includes homes, schools, workplaces, parks and recreation areas, greenways, business areas, and transportation systems. It includes land use planning and policies that impact our communities in urban, rural, and suburban areas. And so it's both the physical that exists, and it is the policies that will someday make the physical exist that constitute this notion of built environment. In New York City, basically, New York City is nothing but built environment. We have a few nature preserves, but otherwise everything in New York City has been built. Even the parks have been built. And so what my team is doing, we're investigating whether differences in the built and the social environment characteristics of neighborhoods impacts the health of the residents of the neighborhoods. And so what we do on a very, very large scale is simply this. We have study subjects from research studies where we know something about where they live, and then we describe their neighborhoods. And so this is a map of northern Manhattan, and I live at 100 Overlook Terrace, and the orange box around my address is my census tract. And that strange polygon that's in yellow around my house is all the space that I can walk to in a half-mile walk along my street network. And so we use that as a working definition of a neighborhood. And we have a study in which we have 13,000 study subjects, and we have generated these definitions of neighborhoods for every single study subject. Obviously, this relies on access to a GIS layer of a street map so that I can figure out how far I could walk in a half mile. And then we want to describe the characteristics of that neighborhood. So you see a few other stars there. 605 Fort Washington is my grocery store. So that's where I buy my fruits and vegetables. And it's handy that that's close to my house. 806 West 187th Street is my local bar that I like to go to after work and have a few drinks. And that may be stress relieving and health positive, or alcohol inducing, health negative. 184th Street in Fort Washington is my subway stop. So I walk there every day. That's a 10-minute walk. It's about maybe about 100 calories I expend getting there. I have to climb 4 sets of steps. That increases my physical activity. And so these are just a few descriptives of my neighborhood. We intensely describe these neighborhoods, and we do it for 13,000 study subjects. We're just going online with a study of New York City children that's going to have 600,000 children in it. And we're going to describe every single neighborhood around every single child. And we rely on administrative data to fill in the information about neighborhoods. And so we use GIS as a framework for linking all kinds of disparate data sets together through longitude and latitude. And so we retrieve information from New York governmental sources, commercial databases, and field surveys. And our perspective is that anything that is licensed, regulated, inspected, fined, or under the purview of New York City government, information about that must exist in a database. So if I want to know where the elevators are, all elevators are inspected every year. That means there must be a database somewhere that tells the inspector where the elevator is. Therefore, I can get that database theoretically, and know which buildings have elevators. And so we take this basic idea and try and utilize that to find data that we can use to describe neighborhoods. And then we have human data that we've collected through epidemiology studies or through Department of Health studies through their administrative data sets. And we use the GIS system to create metrics about what a study subject's neighborhood looks like. And so we do a lot of work on obesity, and I'll show you several slides from the obesity research. And we work with several notions, key notions about neighborhoods. One is walkability. The idea is it's a set of urban design characteristics that promotes pedestrian activity, so that's physical activity, and provides a means where you don't need a private automobile. So driving a car is essentially sedentary behavior. You burn very, very few calories in a car. So if you could be car independent, you're going to be more physically active. Obviously, we're interested in the food environment, the availability of fast food, supermarkets, fruit and vegetable markets. We're interested in the recreational environment, access and quality of parks and ball fields, the availability of commercial, recreation, and exercise facilities. And so we've done a number of studies looking at how the characteristics of neighborhoods influence the obesity or the BMI of their residents. And so we have a study of 13,000 individuals. And we've been working with this idea of walkability, and we wanted to come up with a metric of access to public transit. And so here you see a graph of increasing access to public transit and the average BMI of our study subjects. You see this nice downward trend. It represents about a 1.3 BMI units, which spread out over the population of New York City would radically change the obesity epidemic in New York City if you subtracted about 1.3 BMI units. And so our metric of access to public transit is a census variable, the percent of the population commuting by public transit. And so we can easily download that from the Census Bureau without any problems. We can create neighborhood measures that tell us how many people in each neighborhood use public transit. Here's a similar graph looking at access to supermarkets, produce markets, and health food stores. And what you see again is this trend of downward BMI with increasing access to healthy food outlets. And this works out to be about 3/4 of a BMI unit across the range. And in trying to get the data to describe where supermarkets are, this data is kept by different departments in city government and in DOH. And working with all of those departments to try and find out where the fast food was, where the fruit vegetable markets were, was very, very difficult. It's so difficult in the end that we actually just bought a commercial database for $30,000 that is used for marketing purposes, but tells us where all the businesses are in New York City. And so we ended up, instead of just getting data that should have been available from city government, spending a lot of money to buy the data. And this information is now actually underlying changes in the zoning in New York City. So there are neighborhoods in New York City where you cannot buy fresh fruits and vegetables. There are no produce markets, there's no supermarkets, there's no grocery stores. And so they're changing the zoning to make it easier for supermarkets and produce markets to open up in these neighborhoods, like in central Brooklyn, where you can get Kennedy Fried Chicken, but you can't buy a banana. And so these results are being used as part of the scientific basis for changing parts of the zoning regulation. Here's a similar graph in which we looked at our same healthy food sources data, and we combined it with data from 200,000 New York City births in 2001. And what we're looking at is the odds of maternal obesity. And what you see is as the number of healthy food sources increases, the odds of maternal obesity significantly decreases. And this data, this graph relies on data from the Department of Health's vital statistics. And so the Department of Health maintains information on all deaths and all births. And for births, it maintains information on whether the birth was premature, whether the mother had Medicaid, whether the mother had a prenatal clinic visits, and it has data on the mother's weight. For years and years and years, this kind of data was not accessible to public health researchers. The DOH had it, but they had it under lock and key. And so for years, the Mailman School of Public Health could not access fundamental, basic public health data about New York City because DOH would not share it with us. We've recently brokered an agreement whereby we will have access to vital statistics data, which underlies this graph, which underlies the paper that we're publishing, which is going to underlie the changes to the zoning to make it easier for people to get fruits and vegetables. And so I kind of see this as a win, but it took years to get access to just fundamental, basic public health statistics. We've been looking at the availability of parks, and so this is a map of all the parkland in New York City. It's 29,000 acres. It's 14% of New York City. We wanted to look at the quality and location of parks. So we wanted to know if being near a park and being near a high-quality park was associated with more physical activity and obesity. And New York's, the Department of Parks has the GIS data that tells you where all the parks are, but it also maintains quality metrics. They inspect all of the parks and look at the quality of the parkland for garbage and litter and weeds, whether or not the playgrounds are safe, all of this incredibly important data for understanding why somebody would use a park. And here's the same old graph that I show with my red dots, and here we have a very modest association. It's statistically significant. It's only about 1/3 of a BMI unit. And this represents the percentage of land within a half mile of the study subject's home that is actually parkland. And so this is a rough estimate of how easy it is for somebody to get to a park. And to get this data from the Parks Department, they were really friendly to us for many, many months before they gave us the data. So I had to give multiple presentations to the Parks Department about exactly how we would use the data. I had to go out in the field and actually participate in the data collection process so I would understand how the data were collected. I then had to sign a series of legal agreements specifying what we would do with the data, and then I had to give the lawyer $5. And then I signed an agreement in my own name to get the data. And now we have it, and we have beautiful data about the parks, but it was probably an 18-month process to get information of just where are the parks in New York City. And I have colleagues in San Diego, in and around San Diego, they don't actually even have data on where the parks are. Like nobody's even collected information on where the parks are. So at least in New York City, we have beautiful, crisp data that with work you can get access to. This is my last example. We've been studying childhood asthma and street trees. So New York City has a census of street trees. The idea is if a tree falls in the city, somebody's got to go pick it up and plant a new tree, so they need to know where the trees are. And so here we've combined data on asthma prevalence from DOH with the density of street trees. And what we found is that across neighborhoods in New York City, a 1 standard deviation increase in trees is associated with a 23% lower prevalence of asthma. And so New York City is about to plant 1 million new trees on the streets. And so this kind of information is very helpful for them in thinking about where they're going to plant trees. The U.S. Forest Service has just given us a big grant to really study why it is that trees may prevent asthma. And so we actually have a partnership with the Department of Health and the Department of Forestry in New York City to study foliage and trees and how that might change air pollution levels at the microclimate and how that might influence asthma in little children. But, you know, to underlie this, we had to discover there was, in fact, a Department of Forestry in New York City, and then reach an agreement with them to give us the data on the location of all trees. They wouldn't actually even give us the location, the exact location of the trees. They would just tell us the number of trees on each block. For some reason, the actual location of the trees in our initial relationship was not something that was going to be available to us. Since then, we have a much better working relationship with them, and we are now allowed to know not only the location of the trees, but the width of the tree and the gender of the tree. And so by combining these sort of administrative data sets that are being collected routinely by city agencies, combining them with health data, we can start to understand how neighborhood characteristics affect health in the city. And this kind of data is then fed back to city agencies who are making all kinds of planning decisions about how to improve the city. And we provide them this sort of clues as to how they can improve public health through these kind of data analyses. So the issue here in terms of open data is how to get access to administrative data sets like this. And there is no, in my experience, systematic response across the city agencies. So sometimes it's just a simple download. At one point, I wanted to know where all of the sidewalk cafes were in New York City. It turns out that the agency that licenses sidewalk cafes has a Excel spreadsheet on their website, and you can just download it. So that was super simple. Sometimes it turns out that Columbia already has a license for the data, and so Jeremiah, who's one of the GIS librarians, can help us with getting a data set through the existing licensure that Columbia already has. Sometimes it's a handshake deal with just an agency official. You meet a guy or a woman in their office, you vaguely describe what you want to do, you shake hands that you're not going to do something with the data that is going to make life difficult for the agency, and they hand you a CD-ROM. Sometimes you have to sign data usage agreements, really onerous data usage agreements that Columbia's council office has to get involved in and can take months and months. We were once told, first we have to build a relationship, and then we can sign a license. And so we spent a couple of years building a relationship with an agency, having my students work in the agency, explain them what we wanted to do. We had to build this relationship first. Sometimes we're told, FOIL us, do a Freedom of Information Act request, because we can't really give you the data without having somebody in the agency get angry, but if you FOIL us, that will give us cover to give you the data. And sometimes we just get the stiff arm. No way, no how are you getting this data? And so the primary example of that is the police department. So if you do surveys of parents asking why they don't let their children go out to the parks or the playgrounds, the number one response is, it's dangerous in my neighborhood, there's a lot of crime. And so we want to test whether or not crime has got an influence on physical activity, so we want crime statistics from the police department to match up with our human subjects. And for years and years and years, the police department has refused to give us even just, at the track level of the zip code, the number of crimes. And it's been continuous blockage on that. And getting this data often comes down to my team sitting around saying, I know a guy. I met a guy at a conference. I had drinks with a guy who knew a guy in that agency. Maybe they can provide us with some kind of in. it's completely not systematic. And this is data that's collected with our tax dollars, and there's no systematic way to go about accessing it. And it's an enormous burden to negotiate these kinds of agreements and keep track of all of the licensing arrangements that you've negotiated to get your hands on this data. And then once you have the data, there's this issue of what is my responsibility as the researcher to further disseminate this data to other research groups. And there's two types of data. There's the raw data, and then there's the value-added measurements that I have created from that raw data that represent the creative manipulation of data or the layering of multiple data units together to generate a value-added measure. And some of our data usage agreements prohibit it. They just flat out say we cannot further share this data with anybody. On the other hand, what is my incentive as a faculty member at Columbia to share data with a competing research group? This data forms the basis of my research programs, my grant applications, and my publications, which translates into promotions and tenure for myself and for my colleagues who work with me. So what is my motivation to share the data that I've created or licensed or spent days and days and days schmoozing to get with another research group? When I went up for my last promotion, we talked about my publications, my teaching record. Never once did anybody suggest to me that I would get credit for depositing data in the library or sharing the data with another research group. It's not part of the reward structure under which we're operating. And so it's this disincentive for me to share it. And then once I do share it, because I often actually do share my data with other research groups, managing and monitoring how that information is disseminated is a huge burden. Is it being used within the structures of the licensing agreement that I originally signed? Is it being used within the confines of the agreement I have with the other researcher for what they're going to use the data for? And so we spend an awful lot of time just sort of managing the flow of information that we've created to other groups. And I recently found out that I had given data that we had created from sort of value-added measures to another institution to work on a project. We wrote a nice paper together. It was a great relationship. And then later on, other researchers at that institution, I guess, came across text describing the data and the fact that it was on their hard drives, wrote a grant proposal saying they were going to use these measures and this data, subsequently got the grant proposal, and then called us up and said, all right, so can we have that data you have, and could you tell us how to use it and what you do with it? And I'm on the phone going, what? And so the question is there some central role at Columbia for kind of managing this kind of administrative geospatial data in an organized manner? Because at the moment, it's not chaos, but it's really disorganized, and it's slowing down research. And this is the kind of research that actually the city then uses to set policy and make decisions. So, this is like real-world public health, where we find something out and an agency makes a change, to make fruits and vegetables available. And so this is slowing things down. And I don't know what the solution is, but I've been talking to people at the Population Center here at Columbia about maybe they should have a role in sort of managing and coordinating all of this flow of data that we've been amassing over the last 6 or 7 years. And so those are my thoughts about this. And this is, what I've described here is a lot less organized than what my colleagues here have been working towards. And maybe, up in the public health school, we're far behind what they've achieved, but now we're facing these issues and kind of like looking for solutions on how to make this data open and usable without there being also data anarchy of everybody doing the same thing. So anyway, thank you for your attention.
Okay, so maybe I could focus and also generalize from two of the things, from something you discussed actually in the first talk. So in the first talk, you made passing reference to code, and in particular to different licenses on code. So there was some reference to GPL, BSD, et cetera. Is Creative Commons advocating that code should also be distributed under CC0? Code, when you're a computational scientist, code is sort of like the apparatus that you build. It is also the blueprints for how that apparatus works. And more and more so every year, sort of publishing in 4 pages or 6 pages is woefully inadequate for actually describing what you did. So again, code was not in the title of this session, so I'm sorry for generalizing to code, but since you brought it up, maybe you could discuss a bit about how the panelists in general and also Creative Commons thinks about how code should be distributed. Also, funding agencies was in the title, so I'm curious to know what the 3 of you think funding agencies should be doing. For example, right now the policy of funding agencies is play nice, so we're going to give you the dollar now under the understanding that after I give you the dollar in 6 months or 12 months, you'll be nice, and there's absolutely no mechanism for enforcing that. Some of the agencies don't even say that. So I'd be curious to know your thoughts about code and how it relates to what you discussed in the first talk, and also what funding agencies should be doing differently to help us all. Thanks.
So if I could have a theme, it would be use the right tool for the right job. So free software licenses work really well for software, and so we tend to recommend that you use a software license for software. So we have a research fellow at Science Commons named Victoria Stodden who's working on what we call the reproducible research standard. And essentially the idea is that we would provide a trademark, like a quality, a brand mark that you could use if you were a computational researcher. And to get that, you would say your code is under an open source institute approved software license, your documentation is available under an open content copyright license, and your data is in the public domain. And that's what you would need for the legal reproducibility constraint. And then ideally there would be some element of annotation you would have to have as well. So we would not say put your software code under CC0 and waive the rights. We would actually say use a software license. And so the reason we recommend using a data tool for data is the same reason we recommend using a software tool for software, is that sort of like separation concerns on the internet, you want to use the right tool. In terms of funding agencies, what we've seen is that the funders have the most leverage to change the system, as well as the institutions. Andrew raised a great point, which is that you never get asked for your data impact factor. You don't get judged on the use and the utility of the systems you create. You get judged on these sort of knowledge artifacts that you create. And the NIH moving to force open access to the literature that it funds is one step. The NIH, for most projects over a certain funding level, requires a data sharing plan, but then the data sharing plans are typically not part of the peer review process. So it's a little bit more like play nice. But the bigger the science, the more likely it is that sharing is mandated. And what's interesting from what Andrew was talking about is this is a small group of people hacking away and trying to come up with it. There's no infrastructure to then republish the data the way we have for the human genome or the Polar Information Commons. And so the systems that we've built that work at the big levels, not at the small levels, and that's why we keep talking about the network as a metaphor, which is the network enables everyone to hook their computers up to the internet, not just large institutions with giant mainframe computers. And so we want a system that allows the Polar Information Commons, but also allows Andrew to set up a population sharing system. Wow, those were sensitive.
Well, just a quick thing on the second point. Agencies are taking notice. NSF is thinking about more stringent data requirements. They've always had a data plan paragraph you're supposed to put in there, but it seems rarely enforced. But I think because of actually the OECD document is percolating down. This efficiency arguments are percolating down, and so you are going to see actually more requirements. Another big area that you could spend another whole panel on is well, 2 issues. Is first of all persistent identification of data. In order to have a citation in a like a publication, but for data, one problem is how do you label it? How do you do versioning? How do you find it? So there are a lot of people experimenting with persistent identifiers, and related to that is people discussing how do you change the promotion criteria so that if you have unique data sets to your credit, you can count those as if they were a publication or something. But then you need a whole quality review process structure that's comparable to a scientific paper, and you need systematic ways, at least within defined fields, for the community to come together and agree that that's really a valuable contribution and so forth. So a lot of discussions about this in different fields, different levels of progress in doing those sorts of things. And maybe over a decade or so, we'll get there.
On the funding front, none of my NIH program officers have discussed or mentioned or advocated sharing of the geospatial data that I have. It's never really been discussed, and we've been operating basically on your play nice idea. And so I share the geospatial data I have with people I work with, people who seem like they're good people. There's no like rigorous criteria. Robert Wood Johnson, which funds a lot of health research, is actually further ahead, I think, on this idea. And so they've been pushing standardization of data and centralization and sharing of data so that we can do a study of New York City, San Francisco, Vancouver, and have the same types of data shared across cities so that we can do cross-city studies. But my NIH program officers really haven't ever discussed this.
Just to ask the last speaker, could you continue the story? You were asked to provide data to somebody who'd written a funded proposal. I'd just like to hear the end of the story.
The story hasn't ended. I have a series of meetings coming up. I've had a meeting to express the unacceptable nature of this, and I have a meeting coming up to come to a solution whereby, the project that they're going to do is actually really great, but the way of going about, being a colleague was not so great. And so I want the project to go forward because I think it will be very useful, but we need a way to work together whereby there's an equitable relationship.
So you wish to execute a degree of control?
I don't know if I want to execute a degree of control, but the things that they've promised to do aren't legal under the licenses for the data I have. And so I can't actually give up the data. So the kinds of information they want have to be generated at Columbia by people on my team who are allowed to generate that kind of information. And then the raw data can't be moved, but the derived variables can be moved. But, they're now basically saying, my team has to invest a lot of time and energy and percent effort to generate variables. So we've got to find a way to go forward and make that happen, right? But this is not a system that is sustainable for the next 10 R01s that go in, or the next 10 research projects that go in. So,
I hesitate to ask this question with Jeremiah right next to me, but I just wanted to pick up on your issue about a centralized place at Columbia to manage some of that. Data like the data you're creating?
Provenance of the data. So it's very hard to publish a paper where you explain how somebody at some agency gave you some data and that's the end of the description. We need to have a trail of the provenance of how the information was created at the agency level, what year it represents, what parts of the city it represents. It has to have all this metadata associated with it that basically describe its provenance, because next year there'll be another data set by the agency, right? And so the management of all of that kind of information is very labor intensive and not something anybody on my team was ever trained to do, because none of us were trained in library sciences, right? And so that's part of it. Secondly, the maintenance of the licensing agreements and what you're allowed and not allowed to do with the data, who's allowed and not allowed to see it, is something that also we were, as researchers, never trained to do. And I'm sure there are professionals out there who were trained to do that. And so...
Very few.
Okay. And so those are just two of the big things that consume a lot of time and energy that take us away from doing health research that could, I think, way more efficiently be done in some kind of organized, structured, systematic way centrally.
Well, just, there are really two parts of the problem, I think, that you're alluding to. There is actually a responsibility by the city agencies to do the data management and the metadata preparation that you think should be there and obviously isn't. Our center's done work with Chris Goranson at DOH, where they have a group that's supposed to learn how to do the metadata and properly do it. Obviously, they don't have the resources or whatever to do it completely, to enable sharing of data even within the city, which you would think would be an interest of the city, and of course doesn't help anyone else if they don't do it themselves. I think one of the things that John alluded to is just the power of being able to have digital rights management that's embedded in these licenses is one of the big things that is we have to look to the future so that you don't need cadres of paid professionals who know how to do this. That the machines know how to do it. You can program against it. You can do your mashups, without worrying about it. I mean, without ignoring it, which is the way it's done mostly, but with it properly taken care of. And so, evolving the digital rights infrastructure, I think, is a really important need to enable open access and research that, some groups are investing in. John in particular can probably say a lot more about that.
Well, I mean, we have a narrative publishing industry and tradition in science that goes back to 1665. So that's, Philosophical Transactions of the Royal Society. And that's where citations come from. And so you have author, title, journal, volume, page. And you can get to, in any library that has that journal, you can get to the article. And so you have the publishers talk about registration of an idea by sort of stamping the date onto a text, certification of the idea through peer review, dissemination through subscriptions, and then preservation of the record through this idea of the citation. And so those four functions can be performed weekly by the internet, and that's fine in the cultural world. But in a citation world, when you really want to know, did this data come from John's public health blog, or did it come from the city, right? Because that's actually going to affect it. If you want to extend it, John's molecular biology blog is not as trustable as Columbia Medical Center. And so the ability to view that provenance and understand what it means is one thing. The ability to have it preserved through multiple copies of the data is a second thing. And there is no industry or tradition that exists to do that because the capability economically and technically didn't exist until 10 years ago. I mean, if you downloaded a song in 1998 when iTunes first came out, you remember how painful it was compared to today. So the ability to just physically move bits this quickly is new, and there's no culture. And so we've been trying to argue that the libraries are the natural institutions to play that role because, Science Commons, how many nonprofits are around for more than 50 years? It's like the Red Cross. How many companies are around for more than 50 years?
How many government agencies are around for more than 50 years?
Yeah, remember the War Department, right?
It strikes me as you talk about those two sides that libraries, as you know, are beginning to really look at these issues and look at the responsibility for the metadata description archive. But the monitoring how other people use the data according to the original conditions is not hasn't been done at all. So it's sort of hard to see how anyone actually would do that.
There's going to be some workshops coming up that Nature and some other folks like the Digital Curation Center in Scotland are going to be hosting on what does it mean to cite into a network data model. There are some things we can look at from the cultural web like trackback ping, which we can think about, right? So trackback is an extensible technical protocol. It lets you say, I quoted you in a blog. But you can make it directional and contextual, and you can say essentially, I tracked back to your data set because I used it, and I built derived variables on it. I tracked back to it because my algorithm hit it. I tracked back to it because it's crap, which is actually a really important thing to know, whether or not you're linking to something because it's good or because it's bad, right? And so getting through that sorts of experimentation is where we have to go before we expect a library to actually maintain a meaningful institutional resource. But the librarians have to be willing to engage in that, not think of themselves just as containers of knowledge, that they actually play a role in, sort of similar to being a librarian 200 years ago, which is where you help the searcher get out into the world.
One of the things I've noticed, not to disparage anyone, but one of the things I've noticed in the culture of the GIS world is this very free sharing of data sets. And so it almost seems to me you get a couple of geographers in a room and they start trading memory sticks. And so I have really interesting and amazing data that has come to us that I'm never ever going to use or look at because I have no idea how we got it, where it came from, and where that person got it from. But there seems to be this culture in geography maybe, but as an epidemiologist I've noticed it where there's a lot of trading back and forth of data sets. And that's not usable in an academic world because I can never cite it, I don't know where it came from, I don't know the quality of it, and so that also might be a role for libraries as the, I don't know, authenticator in some manner of that kind of data. So.